This is my multi-agent microgrid program. As you can see, I have used Java programming language, and along with that I have used a framework called JDay in the Eclipse platform. Multiple microgrids make one smart grid. I have used a consumer-friendly algorithm that will ensure that the consumer consumes energy at the lowest possible cost on an hourly basis. Also, the preference is first given to a renewable energy. So this is the prototype that I have built. The potentiometers and LEDs that you see in this prototype is nothing but the agents. That is, in a real-time situation, every solar energy and wind energy will be assigned an individual agent, and this LED and potentiometer pair will together represent an agent. So in a real-time situation, the agent has to send the data to the Java, that is the smart grid system, and receive the data from the smart grid system. In order to send and receive the data, we use the potentiometer LED pair. By doing so, we try to imitate the sensor actuator prototype. Now I'll show a runtime instance of this program. So these are the agents that is getting registered. This is the GUI that is getting opened. And as you can see, the values from the Arduino are being sent and displayed in the console output. So now the output will be coming. As you can see, the first runtime instance is over, and you get a final value of 80 rupees. This 80 rupees is nothing but the amount that has to be paid by the consumer to the grid at that hour. As you can see, this is the LED pattern for this runtime instance, which will be now reflected back in the LED setup with the Arduino. See, you can see the LED, except the last LED is not going because the last bit that was there here was 0, and here it is 0. Let me explain the program. So this is the hostel. I have taken two cases, hostel and department. So hostel is a mini microgrid and department is a mini microgrid. In hostel, at this hour, the load requirement is 147 kilowatts. So first it's getting from the seamless power that is available, and then according to the price, it will first get it from the solar, which is 3 rupees, and then from the wind. So likewise it goes on, and as you can see, since all the it's getting 19 kilowatt from battery, and since all the power is over, the remaining power that is needed is 61 kilowatts. With the help of a multi-agent system, you can do something called non-critical load shedding. So after that, the remaining power that is needed is 13 kilowatts, which is getting from the grid. Because the grid price at this hour is 4 rupees, whereas the standard diesel price is rupees 5. This method is applicable in department also. The potentiometer values can be adjusted to show the varying load in real time.